that? No. Yeah. So do you see the agenda?
Yes.
Okay, so hello everyone. This is a SIG scheduling meeting on 2nd October 2025. We have 4 items in our agenda. Is everyone okay with the order, or do anyone want to add any new point to the agenda? Or shall we start with the first one?
Okay. I can
Okay, so Dominic.
share the screen, or you can open the slides.
Okay, so you could share your screen. I think it would be easier.
Okay. So first of all, we wanted to start with a listing of the things that we plan for 133 release cycle. So can you see what I'm presenting?
Yes.
All right. So so we have several things that we want to have in 135 release, and so we have the dates for like the freezes. So we have 2 weeks to have enhancement freeze, and we have several other weeks for a code freeze, which is November 7th. And we have a lot of items. So we were thinking how to accommodate the CAP reviews and find a time that we can accommodate the implementation. So we believe that the most important thing for the 135 is to have the first step of gang scheduling, the alpha version implemented, and that would be our top priority. We have also few other things that we believe that are important. So I would like to share like how we think the priorities split between them. So I have a question for everyone to let us know whenever we missed some elements, some enhancements that we should consider for 135, both in terms of CAP reviews and code reviews. Yeah, because based on that, we can share the work, especially share the work for CAP reviews because there are a lot of them. So the first list is about the CAP reviews, which does not include the array. On the second slide, I will have those the array ones only. So I can quickly go through the list. So as mentioned, we have gang scheduling, which is our top priority. But we have few others. So we have asynchronous preemption fixes. This is asynchronous preemption is a feature in which we discovered that have problems in 134 that were released. So we had to roll back one of the PRs, and now we have to provide a fix for 135. So that's rather pretty important thing that we need to do.
And it's sorry, Dominic, it's another beta, right? Because it already went to beta in 134, right? Or was it
It's
alpha?
another beta, yes. So there is no change here. Another new thing is a proposal for opportunistic multi-pod scheduling. So Brandon will talk later about this idea and describe what we may do. It's also very important element, but let's keep in mind that it is rather P2. So the next thing is pre-enqueue rejection in pod status. So this is a feature which allows us to set status for things and for pods that remain in pre-enqueue for some reason. We already have a code almost complete, so I think this one has high chances to go through. The next thing is nominated node name delayed binding promotion to beta. So we have implementation in alpha, but the scope is too wide, and the problem is that we decided that we will not go with the complete scope, but we can cut the scope and focus just on delayed binding. This way we can address the problem in communication between scheduler and cluster autoscaler. So we have opportunity to fix some real problems that users notice, and we have to promote it to beta to enable the feature by default, because currently it's only in alpha. From the other things we have in place, pod resize, we promotion to GA. From our side, we only need to review that cap, and I think we more or less agreed that we don't see any issues with that. So it's ongoing. We have a proposal to extend, to add operators to tolerations. So that's definitely on our agenda. Maciek and Kenzie are reviewing this proposal. Later we have node readiness gates. We haven't heard any update yet, so it's unclear whether it will we will keep it in the agenda or not. The next one is node declared features, node capabilities. So we will discuss it later during this meeting. From the DRA, we know that extended resource requests are also have very high priority for us and for DRA. Another one is binding conditions, which also has a high priority. We have device stains and tolerations, partitionable devices, and others. Some of them stay in alpha, so there is reasonably not much update. So we don't expect any surprises here. The two features may be problematic. So binding conditions rely on our nominated node feature. So we have to double check how the changes impact the feature. So we will have to follow up on it. Regarding reserve 4, there are only some early discussions how things should look like. So we are not certain whether it will actually go into 135. And yeah, these are all the caps that we know that we should focus on. We definitely ask for help in reviews. I think Heba, you offer help in reviewing.
Yeah, and I have two comments. The first one for the non-DRA. So we have one more cap related to gang scheduler.
Okay.
If you recall that we are having another cap which is shared responsibility between the SIG scheduling and SIG apps for adding the workload API reference to the job API. So it is mainly SIG apps. So they are the owner. They need to, approve, but SIG scheduling needs to make sure that everything from scheduling is correct. And I'm the owner for this one, so I will not be able to review it. Yeah, this is the first comment. The second comment for the DRA. We have one cap that I didn't see it here. Maybe I didn't read it well, but it's handling the core resource requests through DRA. It is already opt-in for 1.35, and I didn't see it in this list.
Mm-hmm.
I think it's extended resources, right? The first one.
It's another one. There is two: handling extend resources request and handle core resource request.
Hey, hi, this is Praveen. So I added an agenda item for today. It's me who created the enhancement issue. I can talk a little bit more about it.
So is this like a new? Okay.
Yeah, it's basically like we have a DRA driver for CPU, and that is a little different from any other DRA driver. And yeah, like I can talk more about it.
Of course. Yeah. So this is why I just I saw that we have one opt-in and we didn't have it here. Going back to your request or question, yes, of course, I would love to. I already reviewed the gang scheduler for the non-DRA. I had the first round for the gang scheduler because I was part of the discussion since the beginning, and I also reviewed one DRA cap, which is the taint and toleration, device taint and toleration. I had the first round of review. Happy to pick whatever you want. I'm very interested in the opportunistic cache one and any other one. I'm totally open for any other cap to review. Happy to help.
Okay, I was assuming like this cap will have to be reviewed by all the leads.
Yeah.
And yeah, I can add you to this one as well, definitely.
And please feel free to assign me to any other cap that you feel,
Sure.
yeah, of course.
So I think this list will be living with us for longer. So yeah, we can take it offline and track our progress in our reviews here. Okay, so I can now quickly talk about things that we will not working on in this release. So the one that I mentioned, nominated no name for expected placement, we don't have time for that, and also it affects somehow the reservations that we are working on. We don't have time for asynchronous API calls. This is only about ability to have it. Asynchronous preemption, we plan to have it in GA, but because of the problems that we discovered, it obviously cannot be promoted. Similar thing, pop from back of queue. We also see some problems, so we will not have any progress and no graduation. And there is deferred resource quota enforcement. There was a signal that the idea we discussed it on SIG scheduling, but so far we haven't heard any updates, and I don't consider it a part of the plan. So the next thing I can mention is that we have several other items that we believe that are part of the basically workload hour scheduling future plans. So they are listed here. I think we don't have to discuss it now because we have many other items to discuss. But one more thing, we also have split some of the tasks for gang scheduling implementation. And most of them should be covered by us, by Maciek. And here are the API change for the job is here. It's indeed a separate cap. And I think Abdullah can work also on job set and leader worker set, but we need to have confirmation and some update about that. We will probably, yeah.
So actually, I talked to Abdullah yesterday about the job set and the LWS. He mentioned that Erwin will work for supporting gang scheduling for LWS, and Annie, I believe, I can bring the name for the job set, but they are willing to do this work.
Okay.
Yeah, this is one. The second thing, I would love, if this is too much work for you, I would love to help. Maybe just, you can assign to me any of these tasks, and we can work on this in parallel. If this will work well with your schedule.
Okay. Yeah, sure. I think so. Yeah, we can discuss offline which task.
Yes, that's a good idea. Yeah, we could discuss on Slack that.
Sure.
We definitely may need help with integration tests and end-to-end tests, but I guess you are suggesting to take on also some other elements. So
I would love to, if that's possible. So
sure,
I don't have to, read all the code. So, being part of the code it's easier for me to understand while working on it. But totally, it's, let's discuss it. Yeah.
Sure, we are of course happy with your contribution. So,
and of course, I'm happy to, to contribute for the integration end-to-end test as well. I believe these are the most important things. So happy to split the work as well.
Okay, so we have many things in the agenda, so I'm trying to be quick. So let's move on then to the next one, which is opportunistic scheduling. And Brandon.
Perfect. I'll try and take not much time either, but we can hopefully start the discussion. Hello, everybody. So it's my first time in the SIG scheduling, meeting. Happy to be here. So wanted to talk a little bit about the opportunistic scheduling work, and then obviously would love your feedback and comments, both online and offline, as we go through it. So I'd say there's two objectives that we have for this project. The first is to make performance better in some use cases that matter, which is these use cases we see in batch and ML style workloads where you have large numbers of very similar pods scheduling on large clusters. And today our scheduling algorithms n by m, right? So every pod has to be evaluated against every node. And so as the nodes and pods get bigger, obviously, right, the cost of doing that gets higher. So that's objective one. And objective two, which is maybe a little bit sneakier, if you will, is for us to start building some infrastructure around multi-pod kind of scheduling. So to start building mechanisms and frameworks that can help us there. So there are those two objectives in this project that we're trying to balance. So at a high level, the proposal is to add a cache into the scheduler. So the observation is this, which is if you've got a lot of pods that are very similar, what you could do is run one pod through the scheduler, figure out the feasible nodes and their scoring relative to one another. And then right now what we do is we take the first node, we use that for the pod, and we throw the rest of it away. So the proposal is to cache the rest of it. So the next time a pod comes in like this pod, right, of course, finding that as part of the challenge, then we can just use the next element on the list. What was the next best node that we would have used on the previous pod, but we didn't. And that effectively could bring you back to being n plus m, right? So you're only evaluating the nodes effectively once, and then you're pushing a whole bunch of pods through that same definition, so you don't have to go redo the work of doing scoring feasibility. So that's conceptually the idea of the project, and then of course there's a lot of details about how you define those things, which then we can get into. But let me stop first with and just get thoughts, feedbacks on that general idea. Does that seem reasonable to people? Thoughts, and then we can I can go into some of the details about how do you decide pods are the same and what are the challenges and so forth. No comments? Cool. I'll plow on that. Oh, Evan.
I'm just thinking maybe you will cover this in the future, but how about the multi-cluster? Or if we have another multi-scheduler. So if we have another scheduler beside the kube scheduler, how the cache will be handled?
That's an interesting question. I don't know that we've thought too much about how to do it with multiple schedulers, so that may be something for us to discuss. My guess is you'd want to. Yeah, let's discuss that. My guess is that you may want to localize. Actually, that's a fair point. Actually, let me rephrase that. So, yes, today at least the way it works is it's localized by scheduler. So basically, the cache part of the signature of a pod is the scheduler that it's asking for, and so you basically just won't share them across schedulers. Now you get one scheduler can do things that changes things underneath another scheduler, but I don't think this probably doesn't make it worse, or at least not dramatically worse. But yeah, I'm not going to explicitly hit on that, but let's discuss it. And if you have thoughts after we discuss about places where we should look there, please let me know. That's a good comment, good call out. Anything else? Thank you.
Did you mean like two schedulers which are handling as distinct sets of pods, or schedulers like queue and kube scheduler, that one scheduler produce placement for the other?
I meant two schedulers actually, like if we have Volcano running beside kube scheduler. So kube scheduler will be able to cache and like handling all this. But what is the effect, or like what is how the other scheduler will like, is it like working as usual, or is there anything for the life cycle we need to take care of?
Okay, so maybe one detail is important. Or actually, we may need to take it into consideration. Is Volcano setting nominated node names, maybe? Do you know if Volcano sets nominated node names?
Is this question to me, or no, I don't know.
Okay.
Something to look at. So I guess I'll take a note to do this, which is I think this is worth understanding. Again, we thought about it at a very high level here, but I think it's worth a deep dive because there's probably something interesting there.
But I think if a pod has nominated node name, I think we should take into consideration as well.
Yes, we should. Yeah, so if it's using a nominated node name, we should. Although, yeah, I don't know that the current code that I have does that, but we should absolutely have that. Yeah, we shouldn't try and override it if it has a nominated node name. We should just probably accept it. Yeah. Okay. So Volcano, it sounds like multi-schedulers in general, but Volcano in specific is a good thing for us to go through. Thank you. Okay. Anything else? And otherwise let me drive on into some of the details. Thank you. Okay. So the details of this. So there's a couple different challenges, right? So the two things are the cache and then the signature. And I'd say the distinction here is the cache is where the value comes in this first release, but I would say the signature is the thing that we think is more likely to last long term. So eventually the cache probably gets replaced by multi-pod scheduling once we're basically considering pods together. This is in some sense a stepping stone to that. But the signature we expect will be useful both in this world and that world coming up. So So the pod cache, like I said before, basically is just caching the additional nodes there. So it assumes there's a pod signature. So that's just an arbitrary string that describes a pod. And so the expectation is that two pods with the same signature will basically get the same feasibility and scoring on the same set of nodes, right? So not every pod can be signatured, right? Some of our plugins don't facilitate that because they take things other than the pod and the nodes into account. But at least for the customer base we're talking about initially, we think we can basically narrow our scope and avoid those. So in those cases, if a plugin can't assert that, there's a way for it to basically say, we can't create a signature for this pod, and then it just ignores the cache entirely and assumes the cache can't help. Okay, so when the next node comes, we'll pop off that first node of the queue. And then here's where we make an assumption of one user pod per node. So this is actually the way many of these batch and ML applications work, right? So they're scheduling a single pod from the customer, from their end, right? There's a bunch of daemon set pods, but single pod from their perspective per node. And if you make that assumption, this gets dramatically simpler. So we're basically narrowing our scope and saying, at least in this first version, we're not trying to make the cache work for everybody. We're just trying to make it work for this particular use case. And that simplifies some things in important ways, right? So, and here's a key one, which is what we assume is that when a host is used, either by something through the cache or somewhere else, we'll basically remove it from our cache. So the cache is the approach, at least right now, the code has two dimensions, if you will. So you can look up all of the hosts that are associated with a particular signature, but also all the signatures associated with a particular host. And you can do that, ON either way. So when we see a host get used, we just remove it from all of the signatures entries. And if you assume one pod per node, that's safe, or that's correct, right? So everything will behave as it should, because you can't fit another pod on that node. That's by definition. In the case where it isn't one pod per node, this will still be fine from a feasibility perspective, right? You're guaranteed not to get an infeasible solution. So you're not going to suggest something broken, but you are playing a little bit with the prioritization and the scoring. So, the expectation is to need some sort of opt-in either at a pod or at a kind of a customer level, because there will be some effect. We're hoping and guessing that it's probably not a big deal, but we need to see, because it does do some changes if you don't assume that. And then also the assumption is we're trying to handle large jobs, and so this will be a bunch of pods that we assume are coming in a relatively short time frame. So we'll put a very short expiration time on the cache to avoid it getting too stale. So you do run the risk that other things happen around you that you're aware of, pod dies, these kinds of things aren't fit through the cache today. But we'll hopefully only keep them for a second or two, which should be enough to get the value we need. And that means you at least mitigate, if not remove, the risk of getting stale behavior that you don't know. And then I'd also say, once we pick it out, we use the nominated node path right now. So basically treats it as if it had a nominated node name. And so it rechecks the feasibility, so you can guarantee that you won't get an infeasible solution again. You could have drift, a second drift, or whatever it is in the scoring. Okay, so that's the cache, and then again, this is the first version, and I think Wojtek suggested, which I really like, that maybe we use scheduling profiles or something like that to enable something like this, but we can work that out. So thoughts on this, and then I'll go on to the signature part of it.
Yeah. Okay.
Sorry, just one question. The one pod per node.
Yes.
It would work amazing for the normal workload or the current workload, but about the GPU, sometimes they wanted all the workload to run on this specific GPU node. How we will be able to handle this? So
that's a great lead into the signature. So basically, the signature takes a bunch of the stuff into account. So for example, if they say it needs node, it needs a particular GPU, particular TPU, or even a particular node, the cache will handle this by basically making the signatures different. So the signature should include, and there's it's lead into the signature thing. The biggest kind of long-term challenge here is making sure we have a signature that captures all the differences that matter, and that it's a way, in a way that is maintainable long-term. But that's exactly, you'd handle this by basically making sure the two pods have different signatures, and so they won't consider each other.
Nice, very nice. One more question about the queue. How this will, did we think about this use case for having the queue project working with this cache? How this would work, how this would be affected?
I mean, I think it should work. Yeah, we should have probably deeper conversations with ModCheck and others to make sure that there aren't gotchas. Okay. But I believe it should work with the stuff they're talking about that they're doing, because they're basically holding the workloads right until they know that they can be admitted and then releasing them. And in fact, that should, they should be they should help each other, right? They should be synergy, because then you're likely to get them all at once, which means your cache should do a good job of being able to basically sweep them all up. And so this is, again, it's tiptoeing towards multiple pod queuing, right? It's not that far to think, oh, well, why don't we just take a whole bunch of the pods all at once? And then, so, this is tiptoeing into that by saying, rather than changing the loop, let's just cache it from one loop to the other. So I think it will work fine. But again, I think you're correct. We'll need to make sure that we have a deep discussion to make sure there's no gotcha that we haven't seen.
Thank you.
Yeah, so I think if we talk about queue and queue with tasks, then queue is doing the workload scheduling as well. And it will set node affinities. And in fact, pod would have a different affinity, so the cache will not.
Fair point.
But that's expected. Like queue is supposed to do topology-aware scheduling and puts constraint. If there is no topology-aware scheduling, then scheduler can take place a more important role in scheduling, and of course, then we can leverage this scheduling.
That's a fair point. And if it's setting the specific node targets, that's right. Then it doesn't get hurt by the cache, but it also isn't going to benefit from it because it's basically bypassing the scheduler entirely effectively. Okay. Yeah,
I will also mention one important assumption here, that when we reuse filtering results and scoring, then we assume that, of course, pods, those different pods, while they are assigned, they don't change neither filtering results or scoring results.
Yes, and that's hence the timeout, right? To make sure that we have less of a chance of that happening underneath this. Yeah.
Yeah.
Okay, thank you. Good comments. So then move on to the signatures then.
Mm-hmm.
Okay, so signature, the idea is to generate the signature. So it's just a string, and right now, basically, I have a I have basically a first draft of the code, mostly to get people to comment on the strict structure of it and understand if this makes sense. And the proposal would be to add a new call to the interfaces to each plugin. So each plugin would basically be given a node and asked to provide a signature. So basically provide a string that guarantees if two pods have that same string, then they'll get the same scoring and feasibility on the same sets of nodes. And if the plugin can't guarantee that, it can return basically this is not signable. And then again, that means the signature becomes empty and we'll avoid it as we go through the cache. So I put in I took an initial stab at each of the plugins and what the signature should look like. And the doc has those written in kind of plain text, if you will. So what would be really, really helpful is if folks can please, if people are close to these plugins, could go take a look at those. And it's not much code. They're all like 3 or 4 lines, but I think there's a lot of subtlety there. And so I'd love to have people check us to make sure that we're not missing details and important aspects of the plugins. But most of the plugins can generate signatures. The challenging ones are basically pod affinity rules we basically punt on, and also pod topology spread, which is probably the most challenging. We also punt there, but again, for the customer base that we're talking about, these are uncommon things to use, so we think this is okay for version 1. And we can think about whether there's ways of adapting this in version 2. So yeah, I think that's probably a reasonable summary. Other questions, comments? If not, please take a look at the KEP and the code, and feedback is extremely welcome. I'd love to get feedback on this. Any other questions, comments? Then we can go on to the next step.
So one comment. So the plugins which are not in tree, but the custom plugins, by default, they will say that the pod is not cacheable, because otherwise we will risk that we change the behavior of the scheduler.
Yes. So right now, the way I had it built is it's an optional interface. So basically, nobody has to implement it. But then if any of your plugins that are enabled don't implement it, it just effectively turns off signatures for everything, right? because it says I don't, it assumes that the plugin will always return unsignable.
And of course, all in-tree plugins will implement it to enable the functionality.
Yes. Yeah. And then, long term, we can decide whether we make it, mandatory. Of course, everybody's always, welcome to just return unschedulable, or we can keep it, optional this way. And then, yeah, if you don't implement it, you're basically turning off the feature for the cluster, which is fine. Yes. Does that sound right? If there's other trickiness there too, please take a look at that. That's also important.
Yeah, of course, we need to review the cap, and especially Kensei, since he is not here, he has to follow up on the
Yes.
next.
And in fact, maybe I can reach out to him. It might make sense for you to reach out to him directly even and see if I can get him to comment.
All right, I think we will bring it up on the next SIG scheduling on the Asia, and yeah, we can describe and discuss at that time.
Perfect.
Okay, anything else from someone?
Nothing else. Thank you, everybody. Appreciate all the comments and feedback. Look forward to more. Thank you.
Yeah, thank you.
Yeah, thank you, Brandon. So we could move to the next point. So no declared features by Praveen. Do you want to share anything?
I can keep this quick. I was mostly trying to get feedback on this cap. We are planning to have this implemented for 135, and we also have like another feature which is planning to use this as a way to manage like versions queue. But since like Machi, you already reviewed the cap, looks like most of it looks fine, and I'll try to address the comments that you added. Just wanted to check if there is like any other major concerns on this.
Yeah, so from my side, this cap looks good. So only those minor things that I
Okay.
think you already addressed.
Okay, yeah, sounds good. I'll address them today, and I'll resolve the comments. The other thing that I added was like this was something that I was trying to get feedback on. Could I get like access to share my screen?
Yes. Yeah, so we could share now.
Okay, sounds good. Can you share my? Okay, I mean, can you see my screen?
Yes.
Okay,
Yes.
sounds good. So, yeah, this is an enhancement issue that I created and I'm currently like working on. So, we have been working on this DRA driver for CPU like in the last couple of months, and we have like a KH6 repo where we have like a reference implementation for this CPU driver. The main motivation for creating this is like basically we want to have like resource alignment with other DRA drivers like GPU and TPU, NIC, and so on. So currently the main problem was like the other resources are allocated by DRA, and there is no native way for achieving alignment with CPU and memory, which is assigned by kubelet. And this CPU DRA driver tries to solve that problem and also expose like more granular information for users use cases like Slurm, where they want to specify like, hey, I want performance course or efficiency course and so on. So yeah, the reference implementation tries to solve that problem, and with this kept what the problem that we are looking to address is like now we basically have like two mechanisms through which we can reserve CPUs. One is the standard way through the pod spec request and limit, and one is through the DRA, and the DRA exclusively handles like exclusive CPUs for now, and whatever we reserve through the pod spec, it is standard CPUs like or shared CPUs. And now like the problem becomes like in the scheduler, like the current workaround that we have in the CPU, like for the CPU DRA driver to account for this properly is like whatever we are requesting through the resource claim, we also request through the standard resources, so that like the scheduler knows like how much of CPU, or like the node resources fit plugin in the scheduler knows the total number of CPUs that are requested through the resource claim as well. So basically like the two plugins are always in sync by making sure the resources are matching. But the use cases that we are getting, like that we want to solve in the future, is like resource fungibility type use cases, where during the pod scheduling time, like we might not know how much CPUs that is assigned to the pod. Things like newer DRA features, like I think it's called prioritized list, where we can say like, hey, give me like one GPU, but if you don't have a GPU, give me 10 CPUs. So in those cases, like it becomes really difficult to create a pod spec or like modify within the admission controller to update the standard resources part. And this is where like accounting becomes a problem, because like the node resources plugin will look at the standard resources and assumes or has a different view of what the availability of the CPU resource on the node, while the DRA or the dynamic resources plugin has a completely different view of the available resources. So this kept tries to address that by basically trying to have some unified approach, or like a unified model of managing standard resources that are also backed by DRA. So yeah, that is the background. So one obvious solution that we thought about for this is like, hey, like if we have a node which also has CPU DRA driver, let's not use like standard resources at all to specify CPU requests. This is a very clean solution. Like basically you have two ways in the node, like two like either you do all of the CPU related handling in kubelet, or you do in the DRA driver. But the biggest problem with this is like adaptability becomes really slow, because one, we need to implement all of the things that kubelet does within the DRA driver, and the other part is like backward compatibility, like existing workload which are already requesting resources through the standard pod spec will break. So which is why like even though this can be a solution, it would have to be like a really long term solution, and we want to have like something like in the shorter term which can solve like request made through both resource claim and standard resources. Yeah, this is the two like stages that I've defined in this talk, but yeah, I can pause for questions. Dominic.
Yeah. So my question is, you said it will take time to move all the resources to the array.
Mhm.
So we are talking about, of course, CPU memory, which should be easy, right? Because we have the consumable capacity.
Yes. I mean, it should be easy for the like to model these resources on the DRA. I think where it will take longer time is to implement these features within the DRA driver. Thing like everything that kubelet does for CPU, right? Like creating the C group hierarchies and like setting like CPU shares and quota and all of those things. Like basically all of the C group related settings, and also things that are like downstream of that, like eviction, preemption, a bunch of things that kubelet does. We need to have all of these features like implemented on the DRA as well, if we see it as a complete replacement for what we have today.
Okay, but just for scheduling accountability, a consumable capacity should be enough to account the same amount of CPU, but it has to be handled also on the DRA side, on the
Yes.
driver.
Yes, and also like even on the scheduling side, one big concern is like scalability. Like if all of the pods start using resource claim for all of the standard resources, I don't know how much of a overload or overhead it is on the scheduler to process all of these resource claims. I mean, I don't have too much of like I don't know how big of an impact it would be, but that is something that came up in other like discussions so far. Hey Brandon, yeah.
Yeah, so it sounds like, am I right in understanding there's basically two aspects to this? The first is what the interface looks like, so basically how do you define it in the pod spec, and the second is what actually actuates it, so with the DRA driver or kubelet. Is that a fair distinction to make, or am I misunderstanding?
I
It
think
feels like you do those two things potentially separately from one another, or even in different ways.
I think like the interface part, the current DRA interface or like the APIs will be able to handle everything. I mean, all the reservations that we want to do. So we're not adding any specific API on the DRA side as well. I think the challenge is like how do we manage two different ways of reserving a resource. I mean, basically the same underlying resource and two different accounting mechanisms that are like running in parallel.
Got it. Yeah, that makes sense. I mean, I guess maybe to ask the question, I'm sure this is in the doc. I mean, it feels like from the interface, if you kept it just the same and just had DRA do the accounting on the back end, that you might get what you want. Basically, DRA could read both specs, and it's annoying, but you could basically convert the standard spec into an extended extension of the DRA spec on the back end. Or is that maybe that's misunderstanding all the tools that use it?
Yeah, I think like that the concern with that is like the backward compatibility, or we should have some mechanism to convert all of these standard requests through to DRA resource claims, and the other one is like scalability, which I am like not sure how much of an impact it would be.
I mean, guys, is that something you guys are considering, or has it already been decided that we move to the only DRA interface?
Along with these scalability concerns and also looking at the timeline, like I mean, if we want to do like if we want to look at DRA driver as a complete replacement of what kubelet is doing, I think like the timeline is another biggest concern. Like we cannot, I don't, I mean, since customers are asking today, it will take like if we take a couple of years to even like the concern is like we cannot start using it until we build everything, and there is no gradual path to like adoptability. So that is the big concern, I think.
Got it. Makes sense. So let me repeat back what you said is the two systems are going to have to be different on the back end for the foreseeable future because it's just too hard to change it. So we have to come up with how do we make the two of them interoperate, both the front ends and the back ends.
Yes, that makes sense.
Got it. Thank you.
Okay. So
so this is where we need stage one, right?
Yeah, that is why we need stage one, where we would have DRA resource claims for guaranteed resources, but we would also continue using like the standard pod spec for shared resources, like and only like I mean like only pods that care about like guaranteed resources would use DRA based resource claim. Yeah, and coming to like the problem, like one is the obvious one is on the scheduler side. Like we want to manage like we want to account for this both of these, and one is on the kubelet side, like where we've already we already have like all of these mechanisms. Like one of these is C group, one of this is QoS class. All of these needs to start considering resource claims to basically like like set up the C group correctly, or define the QoS class correctly. So this is something that I'm still like exploring. I can add more details. What I wanted to get like more feedback from this session was like for the cube scheduler side, like basically I'm thinking of like on the API side, like what the current thought process is like we would need something like on the node resources plugin to basically say that like this resource claim is not a standard or a regular resource claim, and this needs to be managed differently, and that is done through the device class spec, where like a like a device or a DRA driver which is backing like a standard resource will specify that within its device class, saying this is a core resource that we are managing. And like the scheduler will, the node resources plugin will know that like this needs to be handled in the dynamic resources plugin. uh, and on the accounting side, like what we are thinking is like once the dynamic resources plugin like looks at the resource slice and allocates a specific device or like a count of a device to the pod or the container, we would need something to inform the accounting logic like which happens in the bind stage to basically along with looking at the standard request, also look at the DRA based request to basically compute the node info cache. Like in node info, we have this node info allocatable and requested. And when we compute the requested like resource for a specific node, like we would look at a pod pod status, and within that we would populate like all of the containers and the resource claims associated with them and the quantity of the resource that we are allocating through DRA. And on the binding stage, like basically uh, we look at the standard resource and we look at the dynamic resource. And the way it should work is like for any container, it should have either standard resource or DRA based resource. And if it has both, like the DRA resource takes precedence and the standard resource is ignored. So yeah, this is what we are thinking on the accounting front. Yeah, I can pause here. I'm not sure if that made sense.
Sure. So my question to understand it well, so we will use the array accounting then, or so internally in scheduler when we see a regular resource request,
Mhm.
we accounted for the array resource, or
I think the accounting should still happen by the regular, like the scheduling framework, because if we account it only in the dynamic resources plugin, right, the problem becomes like for a next pod which is not using resource claim, it would be looking at like stale information in the node info cache. So I think like the accounting part should not be, or along with like accounting for allocated devices within the dynamic resources plugin like we do today, we also need another layer of accounting like in the bind stage, because this is also a standard resource and there could be other pods which are not using resource claims at all. So
okay.
yeah, that is the new addition that we want to have, and that is published through the pod status from the dynamic resources plugin. In the pre-bind stage, we will update this pod status, and in the bind stage, the scheduling framework will look at this, and based on this quantity, it will modify the node info cache.
Right. We can take it offline, but I could also think of the approach with generating resource claims for every pod.
Mhm.
And I think we could just do the accounting on the DRA driver side and completely ignore the node feed plugin, but I would have to think twice about that.
Okay, yeah, I think I can explore that
The
further.
rollout,
Too much
I
time.
think, is tricky then, right?
Rollout, you mean?
Well,
Like for existing, like the upgrade for existing clusters that are currently not using the array driver and then start.
Yeah. Of course, the update will be tricky, but in this I think the secondary approach, we are considering that, so we have to solve it anyway. We will always have pods which don't use the array CPU specification, so the problem will always exist.
Okay, yeah, I think I can spend some more time on exploring that further. For now, I haven't thought about like creating fake resource claim within. I think we follow this similar approach for extended resources backed by DRA, but the biggest, I mean, the main difference is like with extended resource on any given node, it is either like we have DRA resource slice or we have extended resource. But with CPU, it would always be like we would have node allocatable as well as resource slice. So that is the biggest difference. But yeah, I can explore further on this.
Okay.
Brandon, like you have your hand up.
I'm just trying to understand. So the proposal here would be if you could specify the CPU through DRA if you chose, is that right? And then it would ignore the normal resource definition?
Yeah, that's right.
So, I mean, I guess, what if you filled in the resource definition from the DRA if you had in this model? I guess, would that be? Okay, let me read the CAP. I think maybe I need to read the CAP before I can have a.
Actually, I had the same thought as Brandon. Why don't we just fill the resource claim with the resources we have, and just like continue everything as usual? Does this even work? Of course, we need to go through the cap, but did you even consider this?
Sorry, maybe I did not understand the question. Like, is it like why are we even filling the standard resource if we have a resource claim?
I guess the question was, are you filling the standard? One approach would be to just fill the standard resource from the DRA claim, right? And then just everything continues to work the way it does today, except you expect DRA is always more restrictive than the kind of the normal plugins. But again, I don't know enough about this cap. I may be asking you to explain a bunch of stuff that we should do offline. But
yeah, I can quickly try to answer that. The reason is like because we would not know always. Like for if like if we have a resource claim, this is a straightforward resource claim, but the resource claim could also be like give me one GPU or something else. So we would not know when we're writing the pod spec, like if we are even allocating CPUs for this pod.
I see. Okay, thank you. That answers the question, and I'll read through the caps so we can have a deeper conversation. But that makes sense. Got it.
Yeah. So it's easier to do it other way around. So for every regular resource, we can generate resource claim. But then we need to have two offerings. One offering which is a regular CPU, and the other offering is a consumable capacity CPU. And we need to have some synchronization on the array driver. Whenever you use one, you have to reduce the other one.
Right. And you're saying the reason we can't just always fill in the existing resources is just it's not obvious what to fill in some DRA claims. So you have to handle having both of them and figure out what you do when they're both set in grid ways and all of the complexity that comes out of it, which makes sense. Thank you. That was very concise and very, very descriptive. Thank you.
I know we are out of time, but if I can quickly answer Dominic's question about like always creating a resource claim, even if only standard resources are specified. I think the biggest concern there comes back to the original like thought. Currently, we are only managing guaranteed CPUs through DRA, and we are not like managing all of the CPU requests, like shared CPU requests in the DRA driver. So we again come back to implementing all of these handling mechanisms like C group and QS and within the DRA driver.
Well, maybe yes, maybe no, but we can just focus on scheduler. So the DRA plugin can have two offerings. One is consumable capacity and another is guaranteed. And whenever the guaranteed is allocated, it deduces the available capacity on the second offering. But I'm not sure if it's just enough to implement it on the plugin side. But we could ignore like what happens on the kubelet side in that case.
Okay. Yeah, let me explore this a little bit more before.
I already put my comments into your doc, so you can.
Oh, okay. I didn't look at that. Thanks for that. So I'll think more and address on the doc then.
But it's definitely interesting. Like one comment, also another comment that I left there is that generating resource claims with some scheduling constraints actually might be even helpful in efficient scheduling.
Mm-hmm.
Because if we schedule a workload and we know that we have 10 pods that consume one CPU, we can generate the artificial resource claim saying that this workload needs at least 10 CPUs.
Mm-hmm.
So when we consider topology-aware scheduling, we could automatically reject topology instances that don't meet this 10 CPU requirement, and just focus on those which does meet that. So what I'm trying to say is that generating several different resource claims from the information that we have might actually help in efficient scheduling, and not necessarily like harm it by, as you mentioned, it generates additional complexity.
Okay.
So I wouldn't worry completely about that. I would rather go into direction of how to leverage putting more constraints, the artificial ones, and
Okay. I'll this is, I think, good feedback. I'll definitely explore more in the doc. Uh yeah, I think I also had like another approach which we were trying to modify within the kubelet and modify the node allocatable. But I think like we discussed on this doc itself that like we would run into some we could run into some race conditions where there is delay in like kubelet propagating this modified allocatable. And I don't even know if it's a good idea to, I mean, right now allocatable is fairly static, and if we start modifying the node allocatable based on DRA based request, there could be downstream effects of that which I'm not completely aware of. So yeah, I think because of the couple of reasons mentioned in this doc, like we are kind of leaning towards having kube scheduler do the heavy lifting and kubelet just do the enforcement, similar to what we have in extended resources and things like that. But yeah, if anyone is interested, like I've explored that model also a little bit on the doc. And yeah, I'll begin drafting a kep based on this doc and the feedback.
I think important information is that we are also working on reservation API. That is a mechanism that will allow to inform kubelet about decisions that a scheduler took. And it should be helpful here.
Okay.
We are also thinking about the reservation of resources for workloads for which we don't have even pods defined yet. So just mentioning that it will address some of the concerns.
Okay. Is this like a KEP, or is there somewhere I can read more about this?
So the work is in progress.
Okay.
We have some internal docs, and we still need to decide on a proposed implementation that we want to share. But I think we are on a good path.
Oh, I see. Okay. Okay. Yeah, I'll take a look at this as well. Yeah, that's everything I had. I can share more updates like once I have like a KEP draft ready.
So I shared this enhancement. This is just a small piece of the reserve problem, but I think Dominic is talking about having new reserved API from scratch. Actually, like that will handle this case and other cases as well. So I believe this is only one case.
Okay. Yeah. I'll take a look.
Is that right, Dominic?
Yeah. So these are connected things. Reserve for is not directly for reservation, but the array probably need to expand in the direction of resource reservation. But reserve for is a mechanism that plays important role, and yeah, I indeed sent yesterday and some idea how we could enhance it and improve the specific problem that this issue is describing.
Okay. Yeah. I think maybe I had like more questions than answers, but I'll continue working on the KEP. Thanks everyone.
Yes, thank you, Praveen, for that. Sorry, we are already a few minutes over time. So yeah, do we have any comments? Okay, if not, we could end the meeting. So thank you everyone for joining today, and see you on the next six scheduling meetings next week.
Thank you.
Bye.
Thank you.